All right, so just want to do a quick review with you on the box method, or in this case, the grouping, factoring by grouping method. But we just basically use the box to do it. So according to this thing right here, we have a polynomial of 4 terms, right? And like always, when we see 4 terms and I ask you to factor it, you would just go ahead and put it in a box. And so I'm just going to go ahead and demonstrate that and put it in a box for you here. As you can see, it flows kind of naturally. C minus 2CD, 8D minus 4. When do we need to switch the last column again?
When there's no left. I mean, when
Yeah, there's no GCF basically. Cannot take out anything on the first important. This is like the very important row right here. First row. If I cannot take anything out right off the bat, I better switch something. But if I can, I don't have to. So let's switch. Let's take out something. Is there anything I can take out? A C. So at least now I know I can take out a C. What about the second row?
A 4.
A 4. You know you can take out something there. 8 and 4. Take out a 4. But the reason this is a positive 4, I just reinforced that, because this is a positive 8, right? First positive, I just leave it alone. But if it's the first negative, I better take that negative outside as well. But now that we have this column established, it's quite easy now to go back in here and say, okay, C times what is C? 1. C times what is negative 2CD? Negative 2D. Okay, watch what happens. This is very important. Please don't blink.
Switch.
What's happening is I take here and I test it. It works fine. 1 times C is C. Negative 2D times C is negative 2C. It's 2 CDs. Works fine. All of a sudden when I do this, I said 1 times 4 is positive 4.
Switch it.
Wait. I know. I expect to see a 4 here, right? And then 4 times negative 2D is a negative 8D. I expect to have a negative 8D here, but wait a minute. First of all, I see they are not in the right place. However, I also discover something different as well. They're in the wrong place, and they're also what? What do you notice? They're the wrong sign. Okay. Remember, I told you that on the inside you can only do the switching. You cannot change anything else other than switching. So let's switch first. If I switch this here, 8D and negative 4, so negative 4 will go here, and 8D will go here, right? What still need to change here? 1 times 4 is not negative 4, so what do I need to modify to make it into a negative 4? What is one thing you have to change? Cannot change anything on top anymore. Because the top is already established. So what do? Think about this. 1 times 4 is 4, but 1 times what here can make it negative 4? And then negative 2D times 4 is negative 8D. Oh, so because I switch it and I want to have opposite sign, and all I need to do is modify that, make it into a negative. There it is.
Oh, I got you. Wait, do it again. I blinked.
Okay, good. No, there's another problem. Don't worry. There's another problem for it. So, see here? Yes, we do need to switch to making sure it's in the right place. But if you notice that it's also the opposite sign, all you need to do is just adjust the number outside to make it the opposite of that. It used to be a positive 4 before. All that I need to do is change it to a negative 4, and it will just kind of, yes?
Is it also because there's a negative sign in the front?
That too, you're right. Because when I switch it, the negative sign, because remember I told you first negative take out, and I have to take that extra negative. Thank you, oh my gosh.
So can we start doing that?
Yeah. But because as soon as I switch it, there's the first negative, right? Then that means I need to take that negative outside as well. Makes sense.
Yeah, you put it like in a complicated way for me.
Okay, great job, wow. Perfect. Okay, moving on. Check this one out. Put it in a box for me, go.
I feel like since she's gone, you're gonna do more of her work.
No, that's not
You're
true.
gonna answer it. Can you give us like 2 minutes?
You can still answer. What do I put inside?
3p.
3p.
Negative 2p squared.
Negative 2p squared.
Negative 18p.
18p.
Positive 27.
Positive 27. Do I need to switch anything yet? No.
Okay. No, yet.
What did I take out? The p. You take out the p.
Okay.
What about this one?
Negative 18.
9.
3.
9.
3.
Negative 9.
Negative 9.
Negative 9. Cause half. Oh yeah.
Negative 9, right? First negative, I take it out, but because GCF for 27 and 18 is 9, I take out 9. And it's a negative 9 in this case. Alright, go back and do the same thing. P times what is 3p? 3. P times what is negative 2p squared?
Negative 2 squared.
Negative 2p.
Oh.
right?
What happens? Oh.
Because p times p is p squared already,
Yeah.
and -2 times 1 is -2. So there it is. So watch what happens. Now that I think about it, it's not always true. Watch. That's 3p, right?
Yeah.
This is -2p squared, right?
Yeah.
And then 3 times -9 is -27. Not here,
Switch it.
but here. And then you can kind of see they're out of place. Then the first thing I do is I switch. So the 27 and -18 will switch places. So here's the the positive 27, and here's the -18p. So after I switch it, I still notice that they're still not the same sign. The two negative here will make it into a positive, right? So I still need to adjust the sign. So what do I do on the outside?
Make that
Oh,
positive.
Very good. There.
Mm.
Which kind of makes sense now. Look. Because this is a positive, the outside has to be a positive. If this is a negative, the outside has to be a negative. There it is.
Check in.
You see how it works? Makes sense, right?
Yes.
Because if you switch it, now I just have to make sure that I take a positive 9 instead of a negative 9 because this is not first negative. Perfect sense. We just discovered that rule. Perfect. Great. And so if I put the whole thing back together, it's simply going to be 3 minus 2p and p plus 9. Some of you asked me, can I write it like this? P plus 9 first and then 3 minus 2p? Absolutely. That's fine. Either way,
Doesn't matter because it's
Doesn't matter. why? Because of what property? Commutative property. Okay, I don't care which order it's in. A times B is the same thing as B times A, or 5 times 4 is the same thing as 4 times 5. Okay, question on this.
I just call it family property.
Okay. So as we get into this new lessons here, I want to introduce this, we'll call it a diamond
I know the first one.
puzzle,
No, you don't.
or method in this case.
We already did it yesterday.
No, you didn't.
I want you to go ahead and figure out something for me here. The top number is always the product of the two side numbers, left and right. The bottom is going to be the sum of the two numbers here that you see. So I'm just going to demonstrate and do the first one for you, and you can actually do the rest. So I see this -8 and 5. First, I take those two and multiply. What is -8 times 5?
Negative 40.
-40. And then now, I take the same two numbers and I add them. What is -8 plus 5?
Negative 3.
Okay. Now, you do the rest. Go.
I'm done.
Oh.
Okay.
I'm done.
Fine, fine. Tell me what to put up here.
Negative 14.
Negative 14.
Okay.
Negative 5.
-5.
Negative 66.
Okay.
5.
Negative 5.
Negative 5?
Oh, no, 5.
Positive 5, right? Over here.
Negative 6.
Okay.
Negative 1.
Negative 1.
Okay. Okay, wait. We're still catching on, I hope?
Divide.
Wait.
Divide.
Hold on. We're good?
I know that one. Yeah.
Hold on. We're still on the same page, right? We're good? Okay. Check this one out though. Notice that I did not give you the left and the right number, but I gave you 6. 6 is considered to be the sum of the product. The sum. So that means -2 plus something will give you a 6.
8.
What is that? 8. Yes. If that's an 8, then what's going to be the top number?
Negative 16.
-16. Okay. Now over here again. If this is a -3 as a sum, 6 plus what will give you -3?
Negative 9.
-9. Does it make sense?
Yeah.
And so -9 times 6,
Negative 54.
-54. So this is something I want you to start doing today. I mean, the toughest part, I would say, is for you to find the right combination to give you the product and the right combination to give you the sum. That's considered to be the hardest. Okay? Now that we have a good idea on how to do this, let's take a look at our first problem. No, don't say that. Okay? Here we go.
Up to her.
So the first thing you see is this. Wait a minute, Mr. Wayne, this is not a 4-term polynomial. I need 4 terms to put in the box. I only have 3 terms. So how am I going to make this into a 4? Well, guess what? Remember I told you that there will be a conversion for this to make it a 3 into a 4? And that conversion requires you to do something with this middle term to kind of split into 2. It's like cell dividing in a sense. You take that cell and divide it into 2 pieces. And so this middle now will divide into 2 pieces. That will make it into 4 terms. You see how it works?
Yeah.
But then how do we get that to divide? Well, this is how it works. First of all, we're going to use that same process that we learned on the previous slide using the diamond. So you have to fill out a couple things. The top is a product. You say, wait, the product of what? Well, as it turns out, it's a product of the first coefficient and the last coefficient. because we're going to be using this cell to divide, so we're not going to use it. So the only thing that you have left is the first and the last number, right? So what is negative 3 times 14? So we're going to use this
Negative 42.
and this. Negative 42, you said. Is that correct?
Yeah.
See it? Okay, here's the bottom. The bottom is going to be the cell that you want to divide. In this case, negative 19. So I'm going to go and place that right in here. So I got my product and I got my sum. Think about this. I need you to come up with two numbers that will give you a product of negative 42 and then add up to negative 19.
Wow.
Huh, see, that's the tricky part.
The what?
Find two numbers that will give you a product of negative 42 that will also add up to negative 19.
Product of negative 42.
So think about that for a moment.
Oh, is 21 and negative 2.
But 21 and negative 2 will give you a positive 19 when you add. So how will you adjust
So
that?
negative 21 and
Aha.
oh. Uh-oh.
Will that work?
Uh-oh.
Think. Isn't negative 21 times 2 negative 42? Negative 21 times add 2 will give you negative 19.
Oh yeah.
Okay, wait. For those of you who's like, how did you get that? Can I just do better another way? Well, yes, you can. Watch this. Here's another way. Okay, first of all,
Well, if you can.
just pretend that. Don't worry about the negative yet. We'll take care of negative later. Just pretend this is 42. Take that 42 and break it down. What do you have?
21.
Break down 42 for me. What times what is 42? Don't use that anymore. Use something that you
6 times 7.
6 times 7, right?
2.
And then 6 is 2 times 3, right?
Yeah.
7 is still a prime, so there it is. Isn't 2 times 3 times 7 42?
Yeah.
Okay, watch. I told you that we naturally use different combination of numbers to get it. So here's my first combination.
I got you.
We're going to use 6 and 7, and obviously it doesn't work. But look. 2 times 21 will give you 42, right? See it? And now all we have to do is adjust the sign to make it fit. We want to make negative 42 and also add it to negative 19. So therefore, if 21 and 2 can be used, I know that 21 and 2, we can actually manipulate the two numbers to get to 19. But, yes,
Why did you do the 2 times 3 times 7?
because if you break this down, is that 2 times 3?
Yeah. Oh, okay.
See that?
Yeah.
Okay, I'm just making, I'm doing a factorization, prime factorization, right? So, I did 2 times 21 will give you 42, but since I want to make negative 42 and also negative 19, that's why I can just tweak it like that and make it into an 821 and 2. So you certainly play around with numbers like that when you break it down all the way. But for certain other values, it's a lot easier for you to just come up with your combination right away. But test it out first, okay? Now that we have the combinations, all that you need to do is circle that and say, yeah, I'm going to be, these two right there will be used to replace that cell inside. That cell now will be divided into 2 pieces, and these are the 2 pieces. Okay, so watch how I'm going to write this from. 14p squared. The last one is still negative 3q squared, right? This cell in the middle will now be split into 2. Which 2? Negative 21 and 2, right? So negative 21 pq and positive 2 pq. You see this cell, pq cell, is being divided into two cells. Negative 21 pq and positive 2 pq. And now we have 4 terms. Okay? So it's like an extra step that you have to do to get a 3 into a 4. Now that we have 4 terms, what do?
Box it.
Box it, right. So here's the box, just like before.
Wow.
It's a small box.
And we have 14p squared, negative 21 pq, we have 2 pq, and we have negative 3q squared. What can I take out?
B.
I know for sure that's p, yeah. What else?
7.
7.
7.
Okay, bottom, second line,
Q.
just the q. Positive q, right? Okay. Okay, now that I have this column filled, what about the top? 7p times what is 14p squared?
Or 2.
2
B.
p. Well, here,
3.
Negative 3.
negative 3
Q.
q. So let's test it to see it works. That one works. 7p times negative 3q, negative 21pq works. 2p times q, 2pq works. Negative 3q times q, negative 3q squared works. So now all I have to do is put it back together, which means it's going to be 2p minus 3q and 7p plus q. And that's how you factor. So, same problem, yes. What's that near to 7? Right here? That's a P. Because I just took out the P. Yes?
How is this used in daily life?
What did he say?
Can you, wait. Shh. Can you wait till we get to the last section of chapter 8? You know, where they talk about projectile. Okay. Oh, wait. Have you ever gone to see the Golden Gate Bridge?
Yes.
Yes.
Yeah.
What?
What?
Never? Oh, you should go. That's why you asking this kind of question. You should go outside and explore. You know how your Golden Gate Bridge has this table that looks like this?
Yeah.
What we're doing here directly, we'll eventually get to that point. Don't worry, relax.
Wait.
Oh, wait. Football.
I love football.
Exactly.
That's
Right.
Oh, projectile motion.
Right.
Football.
What we're doing right here
Yeah.
will allow you to calculate the distance from where you throw to where the catch is. Okay. So, hey, I know what you see here on the surface doesn't have anything to do with in real life, right? But everything that we're doing has to do with it. We can relate to it, right? So, moving on.
Dude, that's scary. Like, you shoot a bullet in the air and it comes down later. What if it just like?
That you can certainly calculate using that too, right?
Oh my god.
Okay, here we go. Here's the next one. Once again, it's a trinomial, right? And we're saying, wait, I need a 4 term. Cannot have a 3 like that, so we need to convert it. But here's something else that you can actually do before you do conversion. Think about this. Imagine if you try to do the conversion right now. You take 30 times negative 54, you're going to get this huge number, right? Which I don't like. Because imagine the bigger the number, the harder it is for you to find the combination. So because of that, always, here's something that you need to remember. Always look for an easier way out. Meaning, can I somehow make my number smaller? Make my number smaller involving, can I actually simplify this? Like take out the GCF? Is there a GCF for 30, 24, and 54?
Yes.
Yeah.
Yes, what is it?
4.
What can I take out here?
Oh wait, no, it's 3.
2.
6. 3.
Just take out 2.
No,
Six?
it's 6.
Okay.
Anyway.
Take out 2 for now.
You can do that
I
gradually,
told you so.
but for people who like know what's going on, fine. Let's take out 6. 6. You can do the ladder. Certainly. If you take out the 6, what do you have left? 5x squared. 4x, right? See that? So now, all of a sudden, I have something that's smaller and easier to manage. So don't, when you see, a trinomial looks really large, big to you, just try to make sure that you get a GCF out. You can, if you can. I'm not saying that every case is going to be workable, but for most cases, you should be able to simplify. But notice, have you also noticed something here, guys? Well, I'll ask you that question again for the next one. But once we have this figured out, let's set up our diamond here on the side. What will go on the top? What do you think?
5.
45 or negative 45? Which one?
Negative 45.
Negative 45. How did I get that? Look at this. 5.
Times negative 9.
See that?
Oh,
There it is.
you got a mold? I like that.
Multiply product on top. Okay, what will be at the bottom? Right here, right? Negative 4. See it? That cells need to divide now into 2 cells. So can you tell me what times what will give you negative 45 add up to negative 4? What times what will give you negative 45? Let's find that first. What times what will give you negative 45? Okay, let's write that first. 9 and 5. Okay, but then we know we want to add, oh wait, 9 and 5, you certainly put them together to get 4 back, right? For sure. But we want negative 4 back, so which number should be a negative? Very good. See it? Because if 5 is a negative, you get a positive 4 back instead. You see it? That's why you got to play around with the sign. But look, negative 9 times 5 is negative 45. Negative 9 plus 5 is negative 4. So these two works. Once we establish that cells, what do we write now inside? 5x squared, what?
Minus
9. 9. Now what?
plus 5.
What cell are we trying to divide? What kind of cell? What kind of term is this? It's the x term, right? So that means you don't forget to attach it with it. Don't just write negative 9 like that. Plus 5x, because isn't negative 9x plus 5x negative 4x? There it is. Minus 9. You see how that works?
Yeah.
Do we have 4 terms?
Do you have to convert it back into that?
No. We want to factor. We want to factor. So now that we have 4 terms, what do we do?
Box it.
Box it. Here's the box. You got 5x squared. You got negative 9x. You got 5x. You got negative 9. What can I take out?
X.
Yes. What else?
Nothing.
2.5.
Wow.
What can I take out? Nothing. So in this case, what do we put? 1. Positive 1, right? Okay, here, let's test it out. X times 1 is 5x squared. 5x. X times 1 is negative 9x. Okay, so this got checked, this got checked. 5x times 1 is 5x. Good. Negative 9 times 1? Negative 9. Checked. See it? So now that we have it, let's put them all back together. 5x minus 9. X plus 1. So this is the factored inside the parentheses. Are we still missing something?
No.
The 6.
The 6. Thank you. Right here. Remember that 6 that we took out at the beginning? Better put it back in. Because otherwise you're going to miss something, right? Okay? Everything has to be accounted for. If you took out something in the beginning, you better put it back at the end. It's still a product. Okay? Any question on that? What do you think? So the hardest part I would say is to figure out the pair of numbers here to give you a product and a sum. Okay? So let's practice this problem here and see if you can actually say anything about this.
Okay.
Okay.
Don't do it for us.
So we'll see a couple problems, right? Do you notice? What do you notice about the power of each variable?
Different.
Look at the previous one.
1, 2, 3.
They're all the same.
They're what? What do you notice about the power?
Oh,
No,
there's
what?
2.
No, look right here.
There's 2. There's 2 of them
2,
instead of 1.
1, 0,
3, 2, 1.
3. What do you notice about the power? They're always what?
Decreasing.
In order.
In order. In what order?
Descending.
Descending. That's the reason why last chapter I said you to put in certain order, descending order, so to speak. This is also applied. You want to put in descending order, you can. But go ahead, try this problem. What would you do first?
Let's do it. I just want it.
You would.
Yeah.
What would you do first for this kind of problem? GCF. Very good. Make it smaller if you can. Can you take out the GCF?
3. 3.
9.
3.
Wait. Okay. For those who said 9, is 21 divisible by 9?
No.
No.
3.
Okay, so 3. Just the 3?
3x.
Probably
3x. 3x.
Let's
do
Because
probably
the x is in first.
Because every single term at least have one x in it, right? And so the lowest one is an x, and therefore you can actually take out 3x for this particular trinomial. So if you take out 3x, what do you have left inside? Look, there's x cubed here, x squared here, there's an x here. Every term has an x in common, right? Therefore I also take that out. If you do the latter, don't you still process the same thing?
Yeah, 6x squared
6x squared
minus 7x squared.
minus 7x, what?
7x. Oh.
You already took out the x, remember?
Yeah.
Minus?
3.
And then it's 3.
Okay. Wait, before we move on. You see what we just took out here? Compared to the previous problem?
Yeah.
And the previous problem? You notice that your first term start with an even power, cannot be an odd. Square. For you to be to make it factorable, your first term has to be an
The
even
greatest
power.
common factor one is.
Okay? Do not forget about that part. Square, because we'll break it and make it a 2 by 2 square. 2. See that? The box has what? 4 boxes. It's a 2 by 2. Even number. So if you see an odd power like that, you better do something first because you can't factor with odd numbers. Okay? Make it even for now. So now with this, what's the first thing you're going to set up? The diamond. What do you put on top?
18.
Negative 18.
Be careful with the sign. It's very important. Is it positive or negative 18?
Negative 18.
What about the bottom?
Negative 7.
Negative 7. Okay. Now, what times what will give you negative 18?
6 times 3.
Add up to negative 7.
2 times 9.
See, 6 times 3 is 18, but you cannot tweak 6 and 3 to give you 7. So you know it won't work.
9 and 2.
9 and 2. That
9
works.
and 2.
9 and 2. Let's tweak this thing. Which one should be a negative?
-9.
-9.
There it is.
Isn't it normally the bigger number?
Well, it depends. If this is a positive 7, then that will be a positive 9. This is negative 2.
Yeah, so whatever. Yeah.
Okay, yes.
I realize that the bottom number is like. Never mind. It's too hard to.
That's fine. That's fine. If you figure out something, it's good for you. Okay. Now that we have that pair, let's write it again. We got 6x squared. This cell right here will be divided in 2. So which 2 will be replacing that?
X.
I mean -9.
9 what?
X.
X. Don't forget, we're replacing the x term, so you better write it again. -9x and
Plus 2x.
plus 2x
-3.
minus 3. Look at that. So we have 4 terms now?
Baby.
Count?
No, yeah.
Yeah, we do. Okay. Here's the box. What do you put inside?
6x squared.
6x squared.
-9x.
Negative 9x.
Positive 2x.
Positive 2x.
-3.
Negative 3. Anything I can take out?
And
Yeah.
3x.
3x.
It's 3x.
Bottom?
And
Just 1. Right. Positive 1, right?
Yeah.
So 3x times what is
2x.
2x? 3x times what is negative 9x?
-3.
So let's test this.
Yeah.
That works?
Yeah.
That works?
Yeah.
2x times 1 is 2x, that also works. Negative 3 times 1, negative 3. So that works.
Rewrite it.
Now, rewrite it. 2x minus 3, 3x plus 1. Did we cover everything?
No.
No.
Get the 3x.
Very good. There's the 3x.
Box that.
There. What question do you have?
No. No question.
So, we're still using the box, right?
Yeah. First time.
We're not changing anything. But the only thing that you have to do extra is to figure out a way to convert 3 to 4 terms. Okay? And I believe this is it. Here's your quiz.
Time. Time.